example. So what type of angle relationship do I have on the first example?
Alternate interior.
Alternate interior. So when we talk about alternate, we're talking about we have this transversal, okay, and they're either, my angles are either on the same side of that transversal or they're on alternate sides. So this is an alternate, these are on all opposite sides of the transversal and they're on the inside, meaning here's my interior, here's my exterior on the outside of those. This is alternate interior. And I do tend to like abbreviate the angle relationships, so I have to write out the words every single time. On the second example, so again, here's my transversal, and I have angles, they're on the same side of that transversal, but what type of relationship is this? What do we call this when one's inside and one's outside?
Corresponding.
Corresponding, yeah. So this is an exterior angle, this is an interior angle. So even though they're on the same side, it's this special, kind of the trickiest one we have to identify, which is corresponding angles. On our third example, here's our transversal. Here are my two angles. What relationship is that?
Exterior?
Exterior, yeah, alternate exterior. Okay, alternate meaning not on the same side and on the outside of the parallel lines. Here's my transversal. What type of relationship do I have here?
Alternate interior.
Alternate interior. And on 5, here's my transversal. What's this relationship?
Same side interior.
Same side interior. The way I abbreviate same side is I just go SSS interior. I could have same side exterior as well. 6 again on the same side, one's interior, one's exterior, and we call that
Corresponding.
corresponding. Good. So you had homework last night. It was just one page where you were labeling what relationship the angles had. So I'm going to just show you my key to that so you can check your homework. Am I okay on the top? Can I move this down? I'm going to move it down. This one's a little bit easier to identify. These are a little bit harder because you have to follow the letters. So like, for example, I'll just do the last one, QTZ. So I'm going QTZ. QTZ would be right here, this angle right here. And PZT, different color, would go from P to Z to T would be this angle here. And then I see that those are on the same side interior of these two lines. Okay, so a little bit more challenging diagram to look at. Okay, any questions on the homework?
Could you go back up? I didn't see the answer.
Yep.
Thank you.
So we're going to, so one thing I kind of changed in my slide deck is we're not going to do everything in notes 2 today. I'm going to keep some for tomorrow in class, but we're going to start the second set of notes. So in your notes packet and B-Day group, I am so sorry for not giving you this packet before you left. I have packets for you that I say B. So I teach at the middle school. Their cohorts are A and B. You guys are blue and gold. Gold group, I'm really sorry for not giving you packets. Just kind of do your best today. It is on the slide deck, so you could print them if you wanted to have the notes packet. Certainly remote students, I hope you do that. But I'll have packets for you tomorrow. Today, the thing I ask is if you're taking notes on a blank piece of paper, because I didn't give you the packet, try to make sure you also draw the diagrams. Don't just write the words because it won't make sense when you go back to it. Okay, so if you do have the notes packet, we're on page 4, and we're going to look at notes number 2. The first page is really quick, and this is honestly just a reference for you. So I'm going to mark on here any pairs of alternate interior angles, and I'm just going to use 2 different colors. So these angles would be alternate interior, and then here's another angle pair that's alternate interior. Same idea for exterior. So this angle with this angle, or this angle with this angle. Those would be my alternate exterior pairs. I have one set of same side interior here. That's a set of same side interior. And I have one set of same side interior here. Same with exterior. One on one side of the transversal, one on the other. So I have these 2 lines, and the transversal, remember, is always the line that's hitting 2 or more lines. So these lines would not be transversals, but this would be a transversal in the middle here. Okay. Now for my corresponding and vertical angles, I'm going to have more going on. So for my corresponding angles, I have inside, outside here. And then on that same side, I also have inside, outside there. And then on the right-hand side of that transversal, I again would have inside, outside pair there. And last, I would have inside, outside pair there. So for each transversal hitting 2 lines, I'm going to have 4 pairs of corresponding angles. Vertical angles, same idea. So vertical angles have nothing really to do with transversals and parallel lines. Vertical angles are from last unit, where we know our vertical angles are congruent. Okay, so these angles are vertical, and in this crisscross, these angles are vertical. So vertical angles here, vertical angles there, and same on the other crisscross down here. Vertical angles here, and vertical angles there. Okay, so they have more pairs given each transversal in 2 lines than the first 4 angle relationships. So we're going to get some practice with this. If you flip this over, there's a diagram. So if you're using a blank piece of paper, I'm just going to give you a minute to draw that. While you are doing that, we need to take attendance. So I'm going to put the attendance link in the chat box. You need to copy and paste that attendance link. Okay, so fill out your attendance. If you need to copy down notes, I'm giving you a minute to copy down notes. Okay. So I'm going to use, I have a pen that I can erase with. You may want to use a pencil and kind of erase as we go. We're going to just fill in, given the relationship it says here, we're going to fill in the other angle for the pair. So first it says angle 1 and angle blank are alternate exterior angles. So which angle would be alternate exterior to angle 1? I highlight my transversal too. So there's my transversal, which angles alternate and exterior. What do you think? You can type it in the chat box too. Gemma, I'm just going to put the attendance link in there one more time. Make sure you fill out the attendance. I hear somebody trying to talk, but I can't hear you very well. So if you want to use the chat box, that's fine too. Angle 8, yeah. So 1 and 8, okay, so they're on opposite sides, connected to the opposite line. 1 and 8 would be alternate exterior. Then it asks, sorry, my dog is trying to talk to us in the background. Can you hear me okay? Yeah, you can. Okay. So then it goes to angle 2, and it asks what angle is on the same side exterior as angle 2. So here's angle 2, same side of this transversal exterior. What would that angle be? Yeah, angle 8 again. So 2 and 8, their relationship is that they're same side exterior angles. Then it goes to angle 3. And it says angle 3 and angle what are alternate interior. Yeah, angle 3 and angle 6. Okay, they are on opposite sides of the transversal connected to the other line. Angle 4 and angle what are same side interior. Again, it's 6, right? I didn't erase it because it's going to be the same angle. They're on the same side of my transversal and they're both on the inside. Angle 5 and angle what are corresponding. This is the trickiest one. Okay, so here's my transversal. What angle would be corresponding to angle 5? Corresponding means, yeah, good. So corresponding means it's on the same side, but if one's interior, the other's exterior, or vice versa. So because 5 is interior, I want the exterior angle up here, which would be angle 1. Angle 6, which is here. And what angle would be vertical angles? 7, yeah. So vertical angles are from the last unit. So across from each other in this kind of crisscross setup. And then angle 7, there's a few options here. So supplementary, this is also from last unit. So supplementary angles, remember, create a line. What angle creates a line with 7? There are 2 answers that are correct. Five. So Michaela, 5 works. Yep. So 5 and 7 create a line that going this way. So angle 5 would work, or not angle 6, because 6 is vertical. What would be the other angle creating a line here? 8. Yeah. So I could also go this way. There's a line. So 7 and 8 would also be supplementary. What does supplementary mean? What's true about those angles? They add up to 180. Yeah, so as we start to, because today we're going to try to build some understanding about what angles are equal to each other, which ones add up to 180. We already know from last unit that supplementary angles add up to 180. So if I knew 7, I could find 8 or I could find 5. I could also find 6 because we know that vertical angles are equal or congruent to each other. Okay, so if I was given one angle in this little grouping of angles, I should be able to find all 4 angles here. Okay. Now the last one's a little bit tricky. It says 8 and what angle are totally unrelated. So we just said that in our little cluster on each side, they're related, right? So yeah, Trinity, you're right. So 8 and 7 are supplementary. 8 and 6 are supplementary, right? They both create lines. 8 and 5 are vertical, okay? 8 and 4 would be corresponding. 8 and 2 would be same side exterior. 8 and 1 would be alternate exterior. 8 and 3 are unrelated because 8 and 3 are alternate, 1 in, 1 out. We don't have an angle relationship for that. Okay, so 8 and 3 are totally unrelated. Now, if we knew 8, we can still get the value of 3 using other angles. And you'll see today how we can, because we're going to learn relationships that kind of cross from one, right? We just talked about we can find all of these, but we're going to be able to get these as well. So you could still figure out what 3 is equal to, but they don't have a relationship that we can that we can name 8 and 3. Okay. All right, so now we're going the other way. So given a pair, what relationship do we have? So we have, and we have a lot of transversals here. So all of these count as transversals. So we have this transversal, and I can look at the diagram here. Okay, so 2 lines crossed by that transversal, that's going to give me angle relationships. I have this transversal, so if I cover up the other half, I could find angle relationships here. And then I have this transversal, so again, if I cover up the bottom of this, I have relationships there. And then I have this transversal along the bottom. If I cover up the top, I'm going to have angle relationships here. Okay, so we have to kind of look at this all sorts of different ways. 15 and 2, I would say, are around this yellow transversal. What's their relationship? Good. Alternate exterior, I see in the chat box. So 15 and 2 are absolutely alternate exterior angles. 13 and 8. So 13 and 8, what is their relationship? Yeah, good. Alternate interior. So they're around this blue transversal. They're on alternate sides interior. Alternate interior. 10 and 12. So here's 10. Here's 12. I would say they're both. So the way I know what transversal to look at is whatever one they're both connected to. So they're both connected to this orange line. I'm looking at that orange transversal. That's one out, one in on the same side of that orange transversal, absolutely corresponding. Yep. Corresponding. 14 and 17. So 14, 17. Again, they're both connected to orange. What is their relationship? Same side exterior, yes. So they're on the same side of this transversal, same side, and they're on the exterior. 8 and 12. 8 and 12, what is their relationship? They are on the same side of that blue transversal. So if it's on the same side, I know it's either same side interior, same side exterior, or corresponding. Yep, same side interior. And 16 and 13. Here's 16 and 13. What's their relationship? Those are vertical. Yep, that's from last unit. 6 and 7. This is again from last unit. So what's true about 6 and 7 here? Yeah, good job, Trinity. 6 and 7 are creating a line. Okay, so they're those supplementary angles from last unit. So we can say supplementary. We can also start calling those what are called linear pairs. Okay, so or lin pair. So they're a pair that's creating a line. And you'll see that mentioned in some of the documents. So linear pair is what 6 and 7's relationship is. 15 and 12. So 15 and 12, what's their relationship? And I would love for more people to participate in the chat. Alternate interior, agreed. And 6 and 5. 6 and 5, they're both connected to this black transversal. What's their relationship? Alternate exterior. 4 and 12. This one's a tricky one. 4 and 12. They're both connected to the blue transversal. Corresponding, yeah. One's out and one's inside. 1 and 3. That's a weird one. Let me extend this line. 1 and 3 are here. Now they're between those two lines. So they're on this yellow transversal between the blue and the black line. What would that be? They're not creating a line themselves, so we can't call them supplementary right now. They're on the same side of the yellow line, and they're inside the blue and the black line. That one's a hard one to see, that same side interior. 9 and 17, what's their relationship? 9 and 17. One in, one out, corresponding. 11 and 12. 11 and 12 are on the orange transversal. And that orange transversal, yep, same side interior on the inside of these two, the yellow and the blue line. Same side interior. 5 and 14. So here's 5 and here's 14. They kind of look like alternate exterior, but it actually doesn't work because it's jumping transversals. So 5 and 16 would be alternate exterior on this line, or 14 and 3. These are unrelated, okay? Because 14 is connected to the yellow and orange line, and 5 is connected to the blue and black line. They're not even on the same transversal, okay? So these are unrelated. 14 and 13 do have a relationship along this transversal. So see how they're both on the orange transversal. And these would be alternate exterior. And the last 3 and 8. 3 and 8 are both connected to the black transversal. What would their relationship be? Alternate interior, yeah. Okay, good. So based on class yesterday and right now, I feel like yesterday we were pretty good at labeling those. We did all right with that today. So now, and I think we won't go much further than this page. We're not gonna finish up notes 2 today. But I do wanna talk about, in order for you to do some of the homework, we got to talk about why do we care about these relationships? So the reason we care about these relationships is because when we do have parallel lines, okay, so I'm going to draw 2 parallel lines. And I'll call this line M and this line N. And when those parallel lines are cut by a transversal, which I'll call T. And so yesterday we talked about this notation tells me that they're parallel. And we talked about this notation, so I can say M is parallel to N, and it is cut by transversal E. Okay. Okay. So now I'm going to label my angles so things can be a little clearer for us. So make sure you label yours the same way. So I'm going to go 1, 2, and then underneath it 3, 4. So there's my first kind of cluster of angles. Then we have 5, 6. And we have 7, 8. Okay. So from last unit, so I'm going to go down to this little table here. So we have relationships that will be true. So we have congruent angle pairs, which means we can set them equal to each other. Okay, so one angle equals the other. And we have supplementary angle pairs, which means they add up to 180, or that one angle plus another angle we can set equal to 180. That's my equation setup. Okay, so I can either set them equal to each other, or I can say this plus this equals 180. And I'm gonna go down to the last box here in this table, okay? From last unit, has nothing to do with the fact that they are parallel. We know that vertical angles are congruent. Okay, that's from the previous unit. Which angles from my diagram up above, and so when I have parallel lines by transversal, vertical angles, they are across from each other. It has actually nothing to do with the two parallel lines. Okay, so I'm gonna have vertical angles here and here and here and here. What would be a vertical angle pair from the diagram up above? So I'll go back up. What would angle 1 be vertical to? Angle 4, yeah. So in terms of equations, I know that angle 1 is equal to angle 4. And I'm going to mark that in my diagram. That 1 is equal to 4. What would angle 2 be equal to? Angle 3. Now I know some things about parallel lines, so I'm going to mark my diagram the way that I know where we're going, okay? What would angle 5 be equal vertical to? Angle 8. Notice I use the same number of tick marks as 1 and 4. Okay, so 5 and 8. So again, if I were setting up an equation, I could say 5 is equal to 8 if I had variables there. And last, angle 6 would go to angle 7. Okay? Angle 6 goes to angle 7. So what I did as I went through that is I purposely marked angles the way I know it's going to work out with our parallel lines anyway. So we have our vertical angles congruent. Now, angle 3, the way I marked this, is also congruent to angle 6, right? I marked it the same. What relationship does angle 3 and angle 6 have? What type of angles are those? Angle 3 and angle 6, or 4 and 5. Those are also marked the same. Alternate interior. So by the way I have this marked, it looks like, my alternate interiors are congruent. And can you also see that my alternate exteriors are marked congruent? So this is new learning, right? This isn't from last unit. This is new with parallel lines. So we also know, so draw a little diagram, that my alternate interior or alternate exterior are congruent. Okay, that's new. So now when we see a diagram, we know that we can set angle 3 equal to angle 6, angle 4 equal to angle 5, angle 1 equal to angle 8, and angle 2 equal to angle 7. That my alternate interior angles are also congruent angle pairs, equal to each other in measurement. There's another box here for congruent angle pairs. So looking at my diagram, what other type of angle have the same, right? So this tells us what's congruent, so we can see our alternates are. What other angle relationship produces a congruent angle pair? Anyone see it? I'll cover up one side. Corresponding, yeah. So 1 in, 1 out, those are the same. 1 in, 1 out here, those are the same, and same on the other side. So our corresponding angles are also congruent. So corresponding 1 in, 1 out. Okay, so equations we could set up. So angle 2 is corresponding with angle 6. Angle 4 is corresponding with angle 8. So I know that they are equal in measure. I should really probably be putting the little m in front of it, but I'm trying to cut down on what we have to write down. Angle 3 and angle 7 are corresponding, so they're equal in measure. Angle 1 and angle 5 are corresponding, so they're equal in measure. Okay. Supplementary angles, so equal to 180. Something that we already know is that our linear pairs, last unit, we know that anything that creates a line is giving me a 180-degree angle. Okay, we know that from last unit. I'm going to go back up to my diagram. I'm going to go with angle 1. What is an angle that creates a line with angle 1? One and 4 would be vertical. These are across from each other. They're not creating a line. But 1 and 3 form a line. 1 and 3 form a line. Or 1 and 2 form a line. Do you see the line formed here and the line formed there? What do you notice here is that this is the 1 arc and this is the 2 arcs, meaning they're not marked as congruent, but it's one of each, right? So I had these congruent angles. I only had 2 measurements all the way around that I marked. Okay, these were all the same. And 1, 4, 5, and 8 were all the same. These supplementary pairs, I have 1 of each. Okay, so 1 and 2, they're a linear pair, so are 1 and 3. So the equation that I would write is I could take angle 1 plus angle 2 and set it equal to 180, or I could take angle 1 and angle 3 and set it equal to 180. This is where it gets a little tricky. What other angle creates a line with angle 2? Okay, so 1 has 2 angles that give me a linear pair. 2 could also make a line with, yep, with 1. What else? 2 with 4. Yeah. So I also can say angle 2 and angle 4 add up to 180, and angle 4 also makes a line with angle. Angle 4 also makes a line with angle 4 and 2, 4 and 3. Okay. So I also have 4 and 3 could equal 180. I think that covers our first kind of clump of angles. And the second clump of angles, angle 5 and angle, what make a line? An angle 6 or angle 5 and angle 7. Okay, so 5 and 6 or 5 and 7. So angle 5 and angle 6 equals 180, or angle 5 and angle 7 equal 180. Now that angle 6 also makes a line with angle 8, yep. And that angle 8 also makes a line with angle 7. Okay, so what I want to point out now is that, how do I want to do it? These bottom boxes here, I try to separate them a little bit. This stuff is always true. Okay, no matter what the diagram is, doesn't matter if we have parallel lines, okay, so we do not need parallel lines, okay? Doesn't matter. Last unit was true, this unit it was true. Vertical angles are always congruent, no matter what. Linear pairs, things that create a line, always equal 180, no matter what. Okay. The stuff up at the top in these 3 boxes, which we still have 1 to fill in, this stuff, this is unique to parallel lines. So it would not be true if I had 2 lines, so I'll just draw it here so I can erase. if I had two lines that weren't parallel cut by a transversal, this stuff, these three boxes, would not be true. Okay, so the three top boxes, this is unique to parallel lines. Unique parallel lines, and that'll become important when we do proofs. Right, any of the stuff up here, alternate interior, exterior, corresponding, or what do you think the other supplementary angle pair will be? Look at my diagram too. Remember our linear pairs had one of each. At the angle. So what's the last relationship we haven't talked about yet? Same sides. So if I look at this diagram on the same side interior, again, notice I have one with one arc, one with two arcs. Same with the exteriors. Okay, so now, again, this is new knowledge. We didn't know this until today. Okay, so anytime I have same side interior or exterior angles, which on a diagram means exterior or interior on the same side of my transversal, we now know that those are equal to 180. So looking at my diagram, angle 4 and angle 6 then must add up to 180. 4 and 6, 2 and 8. Angle 3 and angle what? Did y'all fall asleep on me? 5, yeah. Angle 3 and angle 5 have to equal 180, and angle 1 and angle 7 have to equal 180. Okay, so this is new to us today. All three of these boxes are new to us today. You got the back. Okay. Trying to decide if I want to, yeah, I think let's stop there. That kind of gives us a lot to get caught up on tomorrow, but no, let's do the next page or else you won't be able to do what I'm going to ask you to do. Part of the next page at least. Okay, so now we have this new step. What we are going to do on these problems on the next page says state the postulate or theorem that justifies each statement. Remember our if-then statements, okay? So we are now going to use if-then statements to make a statement about how those angles could be equal or could be supplementary. So I'm going to give you an example with the first one. What type of angle relationship are 3 and 7? I'll cover this up because they're on this transversal. 3 and 7 are what type of angles? Corresponding? Yeah, good. Okay, and corresponding angles should be congruent if my lines are parallel. So what I'm going to write here is if J and K are parallel, then corresponding angles are congruent. Okay? If the lines are parallel, then the corresponding angles are congruent. If this is true, then that's true. The next statement says 6 and 7 equal 180, or 6 and 7 are supplementary. What type of angles are 6 and 7? Same side interior. Same side interior, looking at my table, are supplementary when lines are parallel. So my statement is if the lines are parallel, if J is parallel to K, then my same side interior angles are supplementary. If this, then that. And you could write all the words out if you wanted to. If J and K are parallel, then same side interior angles are supplementary. I just like to shorthand it, save myself some time. Now, when I look at 4 and 6, what is their relationship? 4 and 6 are vertical. Has nothing to do with parallel lines. Okay, so here's like my hint and why we kind of coded this table. This is true. If lines are parallel, then this is true. Okay, there's the if then. If lines are parallel, then this is true. These angles, always true. Okay, so if I'm using vertical angles in a proof or I'm trying to justify it, we don't need this if then. We can just say vertical angles. Okay, because there is no if. Okay, there's no if, it's always. Okay, vertical angles are congruent. You could write that if you wanted to be fancy about it. Okay, but that's always true. There's no if and then a then. 5 and 7. 5 and 7 are alternate interior. Good. That's only true. They're only congruent if the lines are parallel. That's when I need the if then. Okay, so if J is parallel to K, then these are alternate interior, then alternate interior angles are congruent. Okay, dependent on if it's parallel or not. 5 is supplementary to 8. What type of relationship do 5 and 8 have? They're same side interior. Same side interiors being supplementary is dependent on them being parallel lines. That's when I need the if then. So 5 and 8 are only supplementary if J is parallel to K, then same side interior angles are supplementary. Okay, dependent on it being parallel. Angle 1 equals 90. That's just kind of an oddball one. There's 2 ways that you could justify that. You could say this is a linear pair, or you can say it's the definition of perpendicular. Okay, so being able to identify things we know because it's always true, perpendicular is always true, vertical angles are always true, linear pairs always true, versus things that are if parallel, then it's true. You do have something like this on your homework, but you won't have as many angles because it will only be looking at one set of parallel lines. So I think I'm going to limit us. So I'm going to say M and N, so it's not going to be 7, and it won't be 8. And I'll call this L and K. So I'll say list the angles that are congruent to 1 if M is parallel to N. So I'm changing that. So here's my diagram. And I'm only going to look if M is parallel to N. So there are my parallel lines. And here's angle 1. And so congruent to angle 1, which means any angle that falls into this column. So alternate interiors corresponding in vertical angles. Okay, so angles that are congruent to angle 1 could be alternate interior or exterior option corresponding or vertical. So now let's figure out what those would be. So 1 is an exterior, so I wouldn't have alternate interior here. I would only have alternate exterior. So what would the alternate exterior be to 1? I'd only be looking at this transversal. And yes, Jaden, 3 will work, but I'm going to start with alternate exterior. What angle is alternate exterior to 1? like 4, but 4 would not be congruent. So 4 is same side exterior. Okay, same sides are supplementary. Which one's alternate exterior? 8, yeah, 8 is alternate exterior. So angle 8 would be equal to angle 1. So if I knew angle 1, I could find angle 8. Jaden said 3. 3 is corresponding to angle 1. So 1 out, 1 in. So angle 3 we know is equal to angle 1, or I should say congruent. And vertical, what would be the last angle that we would have here? What's vertical to angle 1? Has nothing to do with parallel lines. Vertical angles always congruent. Angle 1 with angle 6, that would be my vertical angle there. And angle 6 would be congruent to angle 1. So if I knew any of those values, I could find all the others, okay, because they're all congruent. Then it says, and so I'm going to change this again to let's switch if L is parallel to K. So now I'm going to look at these two lines, and now it's asking for supplementary to angle 6. So given that I switched it, which it's going to do in your homework as well. Okay, first of all, supplementary is either going to be same side interior or exterior. So that's going to give us a pair, and linear pairs. Okay, there's only 2 supplementary sets. So if I'm looking now at L and K being parallel, I'm going to kind of flip this. If L and K are parallel, I'm looking at this as the transversal now. So I'm flipping which pair of lines I'm calling the parallel lines and which I'm calling the transversal. So what would be my either same side interior, exterior? If this would be interior, okay, because 6 is on the interior. What would be that pair? What pairs with 6 there? 10. Yeah, 6 and 10 are same side interior. So that means that I know that angle 6 and angle 10 add up to 180. Okay, they're supplementary. These aren't equal angles, these are supplementary angles. Okay. What angle would be a linear pair to 6? There's going to be 2 of them. Six and 5. What would be the other one? So angle 6 and angle 5 is going to add up to 180, and angle 6 and angle 2 add up to 180. Okay. So this table, the table we filled out on the other page, is like your golden guide to know, are the 2 angles equal to 180 or are the 2 angles equal to each other? So what I want you to do for homework, I gotta check, I can check your slide deck too, to make sure that I wrote down the right stuff. Okay, so we did our warm up, we went over the homework and we took our notes. So I wrote in the slide deck, not the proofs. I want you to complete the homework. Let's just do page 1, okay? That makes it even a little bit easier. So I'm going to stop sharing. I'm going to share a different screen, and then I'll let you go. Okay, so in terms of today, you don't need to submit homework 16, so I'll edit that in Classroom and make a note to myself to edit that. So I'll edit the due date, because what I want to do is tomorrow, so you have a new slide deck tomorrow. So today you're just going to do the first page of this, and it uses what we just took notes on. Tomorrow will be week 5. So tomorrow in class, I changed this. So we're going to complete the rest of the homework and complete the rest of the notes in class tomorrow. Okay, so if you're not in the full group, you may want to zoom in, because again, this is kind of tricky stuff and it's important stuff. Okay. And then we will do a checkout tomorrow on these beginning properties. Okay. That's going to kind of wrap up the beginning of this unit, because then Friday you're off. I'm not giving you any extra work. All you have is the checkout to complete over that time. And Monday we're off. You can see this screen, right? I'm not, right? Yeah. Okay. Monday we're off. Okay, so then Tuesday we'll pick back up and start notes number 3 and start the second part of this. Okay, does that make sense? Next Wednesday, we're just going to go over homework and start unit review, and you will have your test at the end of it. So I strongly encourage you to show up next Wednesday for that test. There are like PSATs, so I think a lot of teachers are calling classes off. I'm not going to do that because I think anyone who wants to be here, it will help. There is, yeah, Trinity, there's more notes. We're going to do them tomorrow in class. We're going to finish up these next 2 pages tomorrow. And we're going to go over the homework, the rest of the homework together tomorrow. Okay? So all it's going to ask you to do, and I can kind of give you like a preview of homework 16 is, so here's my preview, you can see the beginning ones, is it's going to give you angles, and then it's going to ask what's the relationship, so like the first 2, so if I follow those letters, A, B, F would be here, and B, F, G, B to F to G would be here. And so I said, well, those are alternate interior, which means they are congruent. So don't miss this piece. Okay, are they congruent or are they supplementary? And then the bottom part asks you to do what we just did. So if these lines are parallel, here's angle 3, which angles would be congruent to them. And this is also congruent to them. Okay, so stuff we just took notes on. Use your notes to help you. Okay, sound good? Okay, I'm going to stop sharing.